Alright, on this one we're going to find our mins and maxes by using the second derivative test. So my first derivative, well, I probably would say that this is equivalent to that, just bringing that x up top. So my first derivative would be 1 minus 9x to the negative 2. My second derivative would be positive 18x to the negative 3. So this is the value that I'd be setting equal to 0. And thinking about this one, when is this thing equal to 0? Pretty sure that answer would be never. So still looking at this one, I'd said that it would never equal 0. So I don't know if we could use the second derivative test on this first problem. We could look at the first derivative and find its critical value by setting it equal to 0. We could subtract 1 from both sides, get rid of our negative since both sides has 1, and then I get x squared equals 9, and that happens when x equals plus or minus 3. And so that would match up to what their answers at these x values is where I have my mins and maxes. Since doing this one, I can't set this equal to 0. Like, what would x be to make this thing equal 0? So I would not be able to use inflection points on this particular one. But on our number 4, we had an equation for revenue was negative 8/9 x cubed minus 9x squared minus 27. And so on this one, if I'm finding the first derivative, so I have my constant times 3x squared minus 18x. And then if I take the second derivative, I'd have my constant times 6x minus 18. Simplifying that a little bit, that would be negative 16 thirds x plus 16. So this I could set equal to 0. Let's go to a new page. Negative 16 thirds x plus 16. So if I set that equal to 0, multiply both sides by negative 3/16, I'd get 3. So on this one, I have a inflection point when x equals 3. So I'm going to put x back into my original equation. So I have x cubed minus 9 times 3 squared minus 27. And if I do that, I should get a value of 72. So this is how I find my x value, where that changes from concave up to concave down or vice versa. And if I plug it back into my original function, I'll get that place on my function. So it's at 372 is where that inflection point is, or in this case the point of diminishing returns for the input-output function.